Hi grade 12s. Okay. Our aim with sketching a gradient function is to sketch what the gradient looks like at any part of the function. That means that we're actually wanting to sketch the value of the gradient. And I think the easiest way to illustrate that is to try and give my gradients at various points some values. Okay, they're going to be made up values, but hopefully they'll illustrate the point. The first thing that we need to do when we're sketching a gradient function is to line up a few critical or key points. Now those key points are going to be our stationary points, our points of inflection, and our stationary points of inflection. So let's label those. Over here we have a stationary point of inflection on a decreasing curve. So we've got a stationary point of inflection. Over here we have a non-stationary point of inflection, and over here we have a turning point or stationary point. And those are interesting points, or points in the graph where things are happening. So we're going to draw some guidelines down to our derivative functions so that we know where these things are happening. Alright. And at the same time we can start thinking about what's happening, because we know this is our first derivative, it's our gradient function. Okay, so we know that at a stationary point of inflection our value of our gradient is 0. Okay, and at a stationary point our gradient is 0. Now what I thought might help is if I draw a few strategically placed tangents on my function and I give those tangents made up gradients. Okay, so if I draw a tangent over here, so just touching the line, hopefully you can see it has quite a steep negative gradient, so I'm going to make that gradient negative 10. Okay, if I draw another tangent here, can you see that my gradient of my tangent is less negative? In fact, I'm going to say that one is around about negative 6. Alright, over here I'm getting even less negative, so let's make that one about a negative 2. Alright, over here we go to 0, so if I drew a tangent straight through there, I can confirm that my gradient is 0. And then if I draw a tangent here after my stationary point of inflection, I'm going slightly more negative again, so that looks about a negative 2 again. And if I drew another one over here, that looks like it might be about a negative 4. And through I drew a tangent through here at my point of inflection, maybe that's at about a negative 6. Okay, but then notice after there it gets less steep again, so maybe a negative 4. What I'm doing here is I'm trying to illustrate what's happening to my gradients. Okay, then I get back to a 0, and then I'm getting positive, so maybe this is a 2. 2 or a 4, and then a 6. Okay. Don't worry too much about all these crazy lines. What I'm trying to show you here is let's now plot these values of our gradients. So -10, -6, -2. Well, let's give ourselves some points. So let's make that about a -5 and that about a -10, just to give us a point of reference, okay? So -10 was around about there, then -6, then -2, then we got our 0, and then we went negative again, so it went about -4, and around about -6 over here at our point of inflection, and then it went back to -4, and then we went to our stationary point, and then we went to a +4 and a +6. And hopefully you can see that I've now given myself a few points that I can sketch a nice smooth curve through. Keep in mind that these are made up points, okay? But what it has done is illustrated to me that where I have a negative gradient, okay, I am graphing my gradient function below the x-axis because it has a negative value, okay? And where I have a positive gradient, I'm graphing above the x-axis because it has a positive value. Let's have a look at this next one. So my first, I'm going to do that in a different color now. My first thing I want to do is to look to see what's happening at stationary points and at points of inflection. So over here I have a stationary point, over here I have a stationary point, and I know, I'm going to add it in, I have a point of inflection between those two stationary points where I'm changing from a concave down to a concave up. Okay, so I need to add in an additional line. Just do it in this color, because I know something's going to be happening there. Okay, at my stationary points, I know my gradient value is 0. So this is going to be my f double dash x. It's my gradient of my gradient function. Okay, now let's try to sketch this without drawing gradient lines. I'm going to think about imaginary ones. So if I'm going to draw tangent lines over here, these are all going to be positive, but they're getting less steep. So even if I just took my ruler, I can see, okay, they're getting less positive. Okay, so maybe 10, then 5, then 2. Okay, so I'm expecting that this first part of my graph is somewhere over there. Alright, then after my stationary point, if I were going to draw tangents, I'm going to draw negative tangents. Okay, and they start off not too steep, but they get more and more and more negative until my point of inflection. And after my point of inflection, they're going to get less steep again. Okay, so this is the most negative point. So maybe I was going from a gradient of -2, -4, -6, -4, -2, 0. So at my point of inflection will be my most negative. My point of inflection is my maximum rate of change. Okay, so that means I've got something that looks like this so far. Alright, after my stationary point, I'm going to draw tangents, and suddenly they're positive again. They go from less positive, more positive, more positive, more positive. So I'm expecting something looking like that. Okay, let's have a look at this one. Alright, so what we have is we're going to do our lines down. I've got a turning point over here, I have a point of inflection here. Okay, and at a turning point, here's my first derivative, I'm going to have a zero gradient. Right? Now let's put our ruler on and see. We've got positive, very positive, maybe positive 15, okay? But it's getting less and less and less positive. Maybe positive 5, then positive 2. So coming to my stationary point over there, I'm having a positive, and it's getting less and less and less positive, okay? After my stationary point, my gradient of my tangent is going negative, a little bit negative, and it gets slightly more negative to my point of inflection. So maybe I've got a, maybe negative 1, negative 2, negative 3, okay? And at my point of inflection is going to be my most negative point. Okay, and after that, I'm getting less negative, but it still remains negative. Okay, I'm actually going to redraw that one, else it's not going to line up. So we're going positive, positive to 0. And then we're getting less negative, but it never goes positive, it just remains negative. Okay? And then if we carry that down, at some point here, this thing is concave up, but it becomes concave down. So we're going to select where that point of inflection is, and it's an educated guess, okay? It doesn't have to be exact. But what we have here is we have a stationary point. So we're going to have a 0 gradient there. And now we need to look, okay, cool. We have got negative gradients, and they're going from very negative to less negative to 0. Okay, so I'm going from very negative to less negative to 0. And then I've got positive gradients, but at some point, at my point of inflection, they're going to go from getting more positive to getting less positive. So that means I need to have a maximum positive gradient over there, and then they get less positive again.